Hello, this is the Barton's pendulum, which you have already seen in the previous video. The driver is transferring energy to those 5 pendulums. If the driving frequency matches the natural frequency of the pendulum, then the transfer of energy is going to be very efficient and the pendulum will go into resonance. In this video, obviously the pendulum in the middle has gone into resonance while the other 4 have not. So why is the transfer of energy efficient for the one in the middle but not the other 4? Let me give you a hint. Do you notice that the 2 shortest pendulums are oscillating in sync with the driver? Meaning the driver go left and right together with the pendulums. What about the 2 longest pendulums? They oscillate completely out of sync with the driver. Meaning when the pendulums go left, the driver goes right. But when the pendulums go right, the driver goes left. What about the middle one? Can you see that the driver is always 1/4 of a cycle ahead of the pendulum? Pay attention to when they cross the equilibrium position going leftward, yeah? 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Do you notice that the driver is always crossing on the first beat and the pendulum always crosses on the second beat? There are 4 beats, so this means that the driver is always ahead by 1/4 of a cycle. Based on your understanding of work done by a force, can you figure out why the energy transfer is most efficient when the driver is 1/4 of a cycle ahead of the pendulum? See you at the comments. Ta-ta!